Hi, I'm going to give you a quick tutorial on the fluid flow simulator in UTAPWeLS. This will follow the exercises that we do for the basic invasion initial introduction in our workshops. Um, and so what I'm going to do is start with a new well, and we'll just build a simple model from scratch. Like this. And I'm going to first set the boundaries here. I'm going to set some modeling limits, 1100 to 1200. And then we'll set the viewing limits from 50 to 1250. Okay, and then I'm going to quickly make a few layers for this. It's going to be a really simple model, so I'm just going to put a layer above and below the modeling interval, and then put so I'm gonna zoom in on the modeling interval, and then put one at around 1130 and another one at around 1160. And so, and then once we have that, I'm also going to set up the tracks using you can use the default fluid flow, but in this case, I'm going to use what I just modified that a little bit that you can do with the templates. And so this here you can see I have resistivity and salinity and water saturation as cross plots or as 2D plots, and then I'll have log plots of the Earth model resistivities as well as the water saturation and pressure, which are the main things that are affected by the simulator. All right, so now to set up the model, we'll set some parameters, and so I'm going to open the fluid flow window, which is right up here. And then in this case, we're going to do a 2D because it's going to be really fast for this small model. And we have several different sections in here. So this one determines what simulations are going to run. And the first block here is just in basic invasion. And here we have, for instance, it will show you what all these things are. This is overbalance pressure. And so I'm going to set that to be 300. And we want it to, you can have it anywhere in the modeling interval. And right now it's defaults to the bottom. You can set any type of mud that you want. I'm going to stick with the water-based and very low salt. So coming in with fairly fresh water, and we'll set this at 2 days. If you go on to do formation tests, then you'd set the items in this. That'll be another video. But then here you can set. So you can run several videos, and so or several simulations. So you may want to set something like initial invasion 2 days. And that way I'll show you that you'll be able to tell those apart then later. We also, in this case, to show you how it works, I'm going to add an oil-water contact near the bottom of this modeling interval. So I'm going to set it at depth of 1190, and then you can set some pressure there. I'll set 3700 psi. And then you can set the once you have that set up, then you want to check your grids. And so this shows you actually what grids are going to be used in the simulation. And so you can see when you have an oil-water contact, it automatically will set up some logarithmically spaced grids that are higher density by the contact, and then decrease as you go up here. But we want a little bit more detail than this up here, so I'm going to increase the minimum number to 25, just so that way it will fill in some more grids up here. And then you can see this will tell you the actual number of grids because it may vary based on the settings, depending how it decides it has to lay them out. And then we'll leave the the radial grid's just at 30, but you can increase the number that you want there as well. Okay, so then now we want to have we don't want to use completely default values. So in the layers, so we're going to add some change the layer properties a little bit. So we're going to change the permeability in the R and Z directions. And I'm going to make layer 2, which is this one here, to be 100. I'll leave the middle one 300 and I'll make the bottom 150. Okay, and I'm going to leave the rest of the stuff at default values here. Also, if you want to, you can set the you can set a lot of things in this table. For instance, you can use this table to look at what your wrap classes are set to. So in this case, if you select wrap class here, it'll show you all of them are default wrap class. So if I want to set the middle one to be wrap class 1, assuming that you've made a wrap class 1, which I'll show you in a second, I can do that here. Then you also have options to use the fluids table. Another thing here, which is really important for this, is the PCKR curves. So you can open the PCKR Studio here, and this allows you to adjust the either models or data used to create PCKR curves for every rock class. So here you can select which rock class you want to work on. If you want to make a new rock class, you can just open this up and add a new rock class. In this case, I already have plenty. I'm also going to make sure that my structure consistent. Okay, so I'm enforced. Make sure that this one is enforced. Okay. And so now what I'm going to do is for the default, I'm going to change. Oh, I already have that set to 150. So I had another well here, these are saved for the this particular project. And so this one I have to 150, and then rock class 1, I'll make it 55. And now you can see that these things change the PC curve, and the same thing will happen with the KR curve as well. There's a lot of things that you can do in here to make a really detailed PC KRs for each layer. And then, so finally we have this all set up, and I'm going to run this. And we can see that it runs it here. And if you don't want this to, this is always going to show up, but you can have it automatically close when you're done. I like to leave it open so I can see how it finished. But now that that's done, you have a choice that you can import the results right away to the Earth model, or you can have a look at them first if you want. And this is more important usually for formation tests where you don't necessarily want to import the results. But in this case, you may want to look at the results before you import them for the invasion. So I have it set up here for 9 plots. So I'm going to put them in a window that will have 9 different plots in. And you can, as you see here, there's a lot of different properties you can plot, and you can do it at different times, depths, radius, radii, and you can do vertical cross sections. You'll see what these look like when we hit plot. And so then what you get is you get because we selected like pressure history and radial distributions, we get plots for those. Then you also get the 2D plots, like what you'll see here when you import it. So this is basically shows you what you'll be importing if you select to import this particular sim. And notice up here, we'll see this again in the invasion. This will be a list of all of the sims that you've done for this well. And so you can import any of them that you want, or you can look at any of them that you want. You can go back and forth. You don't have to just do the last one. So now I'm going to import the results. And so I only have one here, so I'm going to use that one. You can select whatever time you want to import if you don't want to import the last one. Or the nice thing about, in this case, I ran 2 days. If I want to see what happens at one day, I can either compare it in the plots or I can just here import one day. I don't care about nuclear, so I can turn off the nuclear sim, but this will automatically run resistivity sim when it's done. So now I hit import, or not a sim, but it'll do a calculation of the resistivity based on the earth model properties. Okay, so now you can see that the things have changed in the earth model here. So let's first look at the two-dimensional cross sections. So we'll look at it out to 2 meters in this case. And we want this to be logarithmic. Okay, so there's our resistivity profile. If you want to see a little more detail, you can change this to be 100. And then we'll look at for the water saturation, we'll go 0 to 1, or maybe we'll leave it at 0.4, but go out to 2 for this as well. Yeah, no, I guess we want to have 0. Okay, so here you can see the variation in the water saturation, and then you can also do the same thing with the salinity. Okay, and so there you can see the where we have water invading down here, and increased water level here. And you can also see the effect of the oil water contact here, and especially you see it when you look at uh, the water saturation curve here. And so if we go back to track 3, look at the water saturation curve, and let's look at the pressure. We know that this is going to be off because we changed it to 3,000. So let's make it, or 3,700. So let's make it 3,500 to 4,000. Okay, so there you can see here the water is 100% below the water oil contact, and then it decreases as we go higher in depth. And you can see we have this linear increase in the water pressure, or yeah, the pore pressure. Now, in this one, we want to see the effect of the resistivity from both the salinity and the water saturation. So we'll go to that track. And this one, we can start with, we can make it, say, 10. See this one. Actually, this one, okay, let's start off with the red one being okay, that's formation. And then it's not much difference between 10. So let's make it something that has a little bit bigger difference. Okay, so there's 8. And then we'll make this one be 5, say. And let's do one more real close to the well, or right at the borehole. Okay. So here's the water saturation at different radii from the borehole. So you can see the effect both of the different rock classes that have different PCKR curves, and as well as the effect of the invasion process. All right, and so that's I think that's all we have for this. Yeah.